Here again, here is to simplify complex circuits. I've already given you example of this house wiring system. There is a complex wiring that is there in the house, but you as an end user only need to know, like, if you want to use a particular appliance, then how much permissible voltage and current that may be passing through that appliance, that is what you are interested in. For that, you don't require to know the whole house wiring system. Okay, so what you need a equivalent circuit. That means the whole house wiring system that will be denoted by the source and a resistance. Okay, and you know what will be the load resistance of the particular appliance you are using. Okay, uh, in Thevenin's theorem, the whole complex network we represented using a particular voltage source, equivalent voltage source, or Thevenin's voltage source, and Thevenin's equivalent resistance, RTH and VTH. Okay. Here in Norton's theorem, we will represent the complex network in terms of a current source in parallel to a Norton's equivalent resistance, RN. Okay. So in Thevenin's theorem, what we did, the whole network was converted into a VTH and RTH, and the RL was there, RL. Okay, so whatever the complex network was, you convert into this. Now, in Norton's, you have to, instead of this voltage and resistance, you have to represent in terms of current and resistance. So one way, um, directly from Thevenin's, what you can do, you can apply source transformation. Okay, that means you can represent a voltage source with a resistance in series that is equivalent to a current source and a resistance, the same resistance value in parallel. Let us say this is R, this is V, then this will be I, that will be V by R, and this will be your R. Okay, so you apply, if you apply source transformation in Thevenin's theorem, you will be getting the Norton's equivalent circuit. Okay, else you can also similar to the Thevenin's theorem, there are some steps, you can follow the steps and you can find out, okay, the Norton's equivalent circuit. So the first, you have to, what you have to do, you have to make the load. In Thevenin's, what we did, we removed the load. Okay, that means we replace the load with a open circuit. Okay, now here what we will do, we will replace the load with a short circuit. Now we have to find out the current that will be flowing through the load. We have to find the current that is flowing through the load. Now current cannot flow through open circuit. For current to flow, you need short circuit, or yeah, a conductor. So here the load resistance will be replaced by a short circuit. Okay. Then what we will do? We will assign a current IN, or Norton's equivalent current, or ISC, short circuit current, that will be passing through that short circuited portion. Okay. So that current you have to find. Then finding equivalent resistance, Norton's equivalent resistance is similar to finding the Thevenin's equivalent resistance. Okay. And then once you get IN and RN, what you will do, you will just connect the circuit. That means IN parallel to RN, and then the load you will connect, and you will find, using the current division rule, you will be able to find what is the amount of current that will be flowing through the load. Okay. A small example here, what is given? Find the Norton's equivalent circuit for the network that is faced by the 1 kilo ohm load resistance. So this is your load resistance. You are interested in finding out what is the voltage across this 1 kilo ohm resistance, or what is the current that is flowing through this resistance. Okay. Now what we will do first, the first step will be to replace this 1 kilo ohm resistance with a short circuit, this one. So you have replaced this 1 kilo ohm resistance with a short circuit. Now, once you have sorted, this is of no use, because the current that will be flowing through here, the whole current will pass through the path which has this resistance, or it has zero resistance. So this black portion that has zero resistance, Simply you are sorting these two terminals. That means the whole current will be flowing through this path. But then the next step, you will be assigning one current. This may be IN or equal to ISC. The same thing. The Norton's equivalent current or short circuit current. Because you are trying to find the current passing through the short circuit. That's why ISC, short circuit current. In both way, you can represent this. Now you have to find this ISC or IN. Okay? You have to find out ISC or IN. Now, here you can see that now the circuit will becomes like this. 4 volt, 2 kilo ohm resistance, another independent current source that is of 2 milliampere. Then again a resistance is there, 3 kilo ohm. This 1 kilo ohm you have replaced with a short circuit, so it will be shorted. Okay, you can either use mesh analysis or nodal analysis. If you use mesh analysis, then this will be one mesh, this will be mesh 2, and you have to use the concept of super mesh because there is a common current source. So without going into that, what you can do, you can apply nodal analysis. Let us say this is the one node, first node, and you are assigning this voltage VA. This is node A, and you are applying the voltage, or you are considering, assuming that the voltage at this node A is VA. Then you apply KCL at node A. Then what you will get? To find KCL, you have to write the equation for all the currents that are flowing. Okay. So in this path, there is a voltage source, there is a resistance, and there is an unknown voltage VA. You don't know the unknown voltage, but the assumption in solving the nodal analysis was that if you are considering a particular node, the voltage at that particular node will be the highest one. So this VA will be greater than 4 volt. Okay, this VA will be greater than 4 volt. So what will be the current flowing through this path? VA minus 4 divided by 2000 or 2 kilo ohm. 1 kilo ohm is 1000, 2 kilo ohm is 2000 ohm. Okay, so what is the net voltage that is being applied across this 2 kilo ohm resistance? That is, at one end of this resistance you are applying VA, in the other end you are applying 4 volt. Okay, but we have assumed that if we are considering the voltage at a particular node, that will be the highest. So VA will be greater than 4 volt. As a result, current will be flowing in this path from higher to lower potential. Current will be from this path. So it is going out. This path means going out. So plus, going out means plus. According to our convention, going out means plus. Then through this path, current is entering. The current source is given. So current will be entering. And how much current? 2 milliampere. So minus 2 into 10 to the power minus 3 because it is milliampere. And what is the current passing through this? So this is grounded. This is grounded. So this is, let us say, on this end of the terminal, you are applying 0 voltage. On this end of the terminal of this resistance, you are applying VA voltage. So the current will be flowing in this direction. So going outward, out from the node. So plus sign. So VA minus 0 divided by 3 kilo ohm, 3000. So the net sum will be equal to 0. Same thing is written here. I just shown how to write this. Now, this is one equation. And there is only one unknown, VA. So one equation, one unknown, you will be able to find out what is the value of VA, that is 4.8 volt. So if the voltage at this point is VA, that is 4.8 volt, then what will be the current? This is the IN. That is the current flowing through this short circuit or ISC. So what will be the value of the current? That is the node voltage divided by 300 ohm. So the current that will flowing will be 4 volt divided by 3000 ohm. You are getting as 1.6 milliamperes. This is the Norton's equivalent current. That means the current flowing through the short circuit. Okay, current that is flowing through the short circuit. Then the next step is to find out the equivalent Norton's equivalent resistance. For that, what you have to do? First, you have to remove the this load resistance. Okay, that means your circuit look like this. This is 3K. This is 2K. This is 4 volt. This is 2 milliampere. Okay. So to find the Norton's equivalent resistance, the procedure remains same as Thevenin's theorem. So first you have to remove the load resistance. That means replace the load with a open circuit, and then what you have to do? Then you have to deactivate the sources. You have to deactivate the sources. You are only seeing the net resistance, the equivalent resistance when you are looking from these two open terminals. Okay. Then the next step will be to deactivate the sources. Deactivating source means replacing that sources, independent sources, with their ideal resistance values, internal resistance values. For a voltage source, I have already said you that the ideal internal resistance is 0. For a current source, the ideal internal resistance is infinity. That means in the next step, what you have to do? You have to replace the voltage source with the short circuit. The resistance will be there, 2 kilo ohm. Okay, you have to replace the current, infinite resistance. So current with open circuit, and the resistance will be there, 3 kilo ohm, 3K, and these two are the terminals. So when you are looking into the terminal, what you are seeing? What is the net resistance? This is of no use. This part is of no use because no current will flow. Whatever current will flowing from this path. So if you ignore this portion, ignore these two portion, then what you are left with? You are left with 3 kilo ohm resistance in series with 2 kilo ohm resistance. This path is not there. That means the net resistance, or Rn, will be the sum of 2000 ohm plus 3000. That means 5000 or 5 kilo ohm. Next, you have achieved both the Norton's equivalent current and Norton's equivalent resistance. As a result, you can draw the equivalent circuit. That means this will be the current source. Let us see what was the value. Value was 1.6 milliampere. Okay, 1.6 milliampere. Then in parallel, there will be the Rn. Rn you have already found, that is 5K. And then you will reconnect the load. Load is of 1 kilo ohm. RL. Then finding out let us say you want to find out the current that is flowing through this 1 kilo ohm resistance. Then you have to apply current law, because this is a current source, and at this point it will divide in two parts. Now, in which is how much amount of current will flow in each part, that will be given by your current division rule. That means when you are trying to find what is the current through this 1 kilo ohm resistance, that means current flowing through 1 kilo ohm resistance, that will be equal to, in the numerator you have to write what is the resistance in the other branch. Okay, other parallel branch. So this is one branch, let us say. What is the resistance in the other parallel branch? That is 5000 divided by the total resistance of these two. That means 5000 plus 1000. multiplied by the net current. Net current is 1.6. So 1.6 milliampere is getting divided in two parts, this and this. So multiplied by 1.6 10 to the power minus 3 milliampere. Okay. So in this way, you can solve this Norton's theorem. Now let us solve another problem or another example of Norton's equivalent circuit. So this is, let us say, the given circuit to us. You have to find out the Norton's equivalent circuit with respect to the terminal sense. So this is terminal A, terminal B. So from this, let us say the load is connected here. Then you have to apply Norton's theorem. Okay. So here the load was connected, let us say. Now the first step you have to do, you have to remove the load. So that's what has been done here. They have removed the load. Then what you have to do, you have to replace the load with a short circuit. That means you have to short them and assume that current IN flow through this path. And you have to find out the value of this IN. So how much current will flow? Which method will you use? Which method will you use? You have to find out IN. You can use mesh. You can use nodal analysis. Try to find out what is the IN. What is the value of IN that you just try. Okay, 10 by 3. Others, try to solve this IN. Try to find out. We will see other methods of also when there are multiple sources how to solve. We will see next. Okay, in the next theorem. But from whatever you know, can you solve this? Others, what are the answer you are getting? Yeah, you can do anything. Mesh analysis, nodal analysis, anything. Okay. This is your circuit. So let us say you're applying nodal analysis. So you consider this as node A, let us say you are considering VA. So apply, you don't know what is this current. Let us say the current is in this direction, ISC or IN. Okay. So in this branch, what will be the current that will be flowing? VA minus 10 divided by 5. Here, let us say current is going outward. So this is plus also because current will be going outward. Here also let us say current is going outward. So plus IN. Here also current is going outward. So plus VA plus VA minus 20 divided by 15, that will be equal to 0. Yes. Yeah. Right. Then you can apply that and you will be able to find out the current IN. Because here, if you consider this as ground, then this is short circuited. Okay, so VA will be equal to 0. So IN you can find out as 10 by 5 plus 20 by 5. So 20 by 15. Okay, you'll be able to find out the value, that is 3.33 ampere. Similarly, you can apply KVL, mesh analysis also. So this is mesh 1, this is mesh 2. You can apply that. Okay. In any way, uh, also you will see another. So using superposition theorem also you will be able to find out. So yeah, you can also apply mesh analysis and see whether you are getting the same answer. So this is, in this way you can find the short circuit ISC or IN. This is equal to IN. Next thing that you have to find is RN. For RN, what you have to do? You have to keep it open circuit. It was open circuited. These two terminals was open circuited. Now you have to look through these two terminals and see what is the net resistance that you are getting. So it is actually open circuited. It's okay. You have to deactivate the sources. That means replace the sources with their internal resistance. So both are voltage source. So the internal resistance, ideal internal resistance are 0. So you replace them with short circuit. You replace them with short circuit. Now, if you see, this is A, this is B. Okay. Between A and B, it has two paths. In one path, there is this 5 ohm resistance, and in the other path, there is this 15 ohm resistance. So between A and B, what will be the equivalent resistance? That will be the parallel connection of these two resistances. That means Rn will be 5. Okay. Okay. So the equivalent resistance will be, if you solve this, it will be 3.75 ohm. So once you got the equivalent, Norton's equivalence, forget about ZeQ, it will be Rn. It will be Rn. Z will come when we go to the AC analysis, AC circuits, then Z will come, but here it is Rn. So Rn you have found, Rn is 3.75 and In you have found 3.33. Now, once you have got it, then it is easy. That means AB will be there. This AB will be there. And here there will be a current source. And there will be a resistance. Resistance of value 3.75. Rn is equal to 3.75 ohm. And this In will be 3.33 ampere. Okay. So this is your Norton's equivalent. Norton's equivalent circuit. But from Norton's again, you can find out Thevenin's using simple uh, source transformation. So what will be the equivalent Thevenin's theorem, a Thevenin's equivalent circuit? Again, you have to find out what will be the voltage across this resistance. That means V equal to IR. What is the current flowing? I is 3.33, R is 3.75. Okay, you will find out the value of V. So that value of V plus minus, and in series the resistance will be there, that is 3.75 ohm, and then this will be the terminals A and B. So using source transformation also, you can find out what will be the Thevenin's theorem. Okay, Thevenin's equivalent circuit from Norton, Norton's equivalent circuit from Thevenin's. Okay. This is our second theorem. So there are four theorems, Thevenin's, Norton's. Next, we'll move into superposition theorem. Now, this circuit that you have seen, there are two independent voltage sources. Okay, when there are two or more than two independent voltage sources, then how to simplify the circuit or to solve the circuit in a simplified manner, that we will see. Okay, that we will see next. So if you have any doubt in Norton's, please let me know. Otherwise, I will start the this superposition theorem. Let me keep this problem once. Just see into it, and if you have any doubt, let me know. I will give you 1 minute, 1 or 2 minutes. Okay, then I will move into the next theorem. By that time, if you have any doubt regarding this, please let me know. Sir, when to apply Norton's and when to apply Thevenin's. So if it is, it means both can be used anytime, but the in order to simplify things, when you have to find out what is the voltage across, uh, what is the voltage across a particular load resistance, then you can use Thevenin's. When if it is asked to find out the current that is flowing through that particular resistance, you can apply Norton's. But as you have seen, if you know the voltage across a resistance, you can find out the current. If you know the current that is flowing through a resistance, you can find out voltage. So you can apply any of the concepts. Okay. Also, from the method also, you can see that if you know Thevenin's, just using source transformation, you can get Norton's. If you know Norton's, using source transformation, you can get into Thevenin's. So there is no hard and fast rule when you to apply. Whatever you are comfortable with, you can apply. Okay. If it is mentioned in the question that, okay, apply Thevenin's theorem, then you have to apply Thevenin's theorem. Otherwise, in practical cases, you can apply anything. Okay. Next is superposition theorem. That means when to apply superposition theorem, when you have multiple independent sources. When you have multiple independent sources, then you mainly apply superposition theorem. But to apply superposition theorem, the circuit on which you are applying superposition theorem, it has to satisfy some condition. The first condition is the circuit should have at least two independent sources. If the circuit has one independent source, then there is no requirement of using superposition. When the circuit has at least two, that means it can go till 100, 1000, anything, at least two, then you can apply superposition theorem. Then what is the next requirement? The circuit should be linear. That means it should contain linear elements. We have already seen linear or non-linear elements. Diode we have seen it is a non-linear element. Okay. Linear means the voltage, okay, or the current that is flowing through a particular element that will be proportional to the voltage you are applying across it. So I will be directly proportional to V. If you want to replace this proportionality sign, I will be equal to V by R. I equal to V by R or V equal to I or anything. Okay. So linear relation between I and V. In diode, it is not the case. So that's why it will be a non-linear element. Okay, you cannot apply superposition theorem in non-linear element. Okay. Next is bilateral. It will be bilateral circuit. That means all the elements should be bilateral element. Can anyone give the answer? What is a bilateral element? We have already done this part. What is a bilateral and unilateral? Two things we have studied. If you remember, please let me know in the chat. What is the definition of bilateral element? That means the circuit with all bilateral elements that will be there. You can apply superposition theorem. Can anyone write in the chat? What is a bilateral element? Quickly write in the chat. Yes, on changing polarity of the voltage, current doesn't change. The magnitude of the current doesn't change, but the direction will change. Okay. Polarity dependent. Yeah, both direction. That means if this is the resistance, okay, this is the voltage source plus minus. Okay, this is R, this is voltage V, then current I will be flowing from this direction. So this will current I. Okay, if you change the polarity of the voltage source, that is this is plus, this is minus, and you are applying the same resistance R here, then the current direction will change. Current will now flow from this direction, but the value of the current will be V by R. Again, here the current of the value of the current will be V by R. So current value is remaining same, but the direction, initially the direction was from left to right. Now the direction is from right to left. Okay. So the magnitude of the current is independent of the polarity of the voltage source. Definitely the magnitude, direction will change. The direction of the current. So if the circuit has only bilateral elements, then you can apply superposition theorem. If it is a unilateral circuit, you cannot apply. Next requirement, the circuit should be active circuit. That is only like if there are two independent sources, that means the circuit is active, because sources are active elements. Okay, any kind of source is an active element. You can supply energy. So these are the requirement. These are the requirement. That means it should be an active circuit, first one. That means some sources should be there. It should at least contain two sources, two independent sources. Second condition. Third condition, linear relationship between I and V, current and voltage, and bilateral element. That means if you change the polarity of the source, voltage source, your current direction may change, but the magnitude of the current remains same. So if any circuit satisfies these four conditions, then you can apply superposition theorem. Okay, that is what it is written here. In a linear network containing more than one independent sources and dependent sources, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone. All other independent sources being represented meanwhile by their respective internal resistors. Let us see from this simple example. There are two sources. There is this voltage source, there is this current source. Again, both are independent. So this is plus, this is minus, the direction of the current source is given. And some circuit is given to you, R1, R2, R3, R4. Then what does the superposition theorem tells? That if you apply, there are two sources. If you apply any of the source one by one, let us first deactivate the current source. Deactivating current source means replacing that element, the current source, with its internal resistance in ideal case. In ideally, the internal resistance of the current source is infinite. That means if you replace this current source with an open circuit, and then you apply, let us say, V. Okay, then you apply this voltage V. You will find out what will be the current that are flowing through here, what will be the voltage drop across this, those things you can find. Next, what you do? Now you deactivate the voltage source. Deactivating voltage source means replacing this with a short circuit because its internal resistance is zero, almost zero. Now we apply the current source, and you will be able to find what will be the different currents that are flowing through these resistances. If you know the current value and its resistance, then you can find what will be the voltage across these resistances. Now let us consider the resistance R. In the first case, you will also get, when you have applied voltage V but deactivated the current source, let us say you are getting VR31. This is the voltage across the resistance R3. When you are deactivating the voltage source and you are applying the current source, you are getting another voltage V2R3. Okay. If you applying superposition theorem means if you add these two, that will give you the correct answer. That means when you are applying both the sources, whatever the voltage across the R3 will be, that will be this one. Let us find out. Let us apply this one now. Okay. First, in the first case, what they have done, they have replaced the current source. Here the current source was there. They have replaced the current source with the open circuit. Now, what they are doing, they are trying to find out what is the current flowing through this R4. Let us say that is I4 dash. Now, I4 dash, how we can find? Okay. Now, you have to see what is the equivalent resistance. I is the, but to find out, first you have to find what is the current that is flowing through this path. Okay. Let us say current I is flowing through this path. What will be the current I? That is the voltage you have applied divided by what is the equivalent resistance. Okay, this path you can neglect because it is open circuit, no current will flow. So you can remove this part. Okay, so what will be the total current? That is R1. This is in series with this. Okay, in series, so plus. And R2 is in parallel with R3 and R4. So R2 multiplied by R3 and R4 are in series. So this is the current I. This is the current I that is flowing through this. When it is coming to that node, it has two paths. One path goes through here, one path goes through here. What you are interested in, finding I4 dash. That means what is the current flowing through this path. So again, using current division rule, we want to find out I4 dash. So I4 dash will be, again, in the numerator, you have to write the resistance in the other path. What is the other path? That is this one. When you are trying to find the current flowing through this branch, what is the other branch? That is this one. That is, what is the resistance there? R2 divided by the net resistance in both the branches. That means R2 plus R3 plus R4 multiplied by the net current that is coming here. That is I. So this is nothing but I4 dash. It is the current flowing through R4 resistance. Similarly, now in the next part, what we have done, we have deactivated the voltage source. We have kept the current source, but we have deactivated the voltage source. Again, deactivating voltage source means we have replaced that with a short circuit. Next, we are trying to find what will be the current flowing through this R4. Let us denote it as I4 double dash. What will be I4 double dash? Again, net current is flowing I here. Coming here, it will be divided in two paths. That is this path and this path. First, you have to find the net current is already given. Current I is flowing through this part. So again, using current division rule, I4 dash will be net current multiplied by what will be the numerator? In the numerator will be the resistance in the branch opposite to this one, R4. That means this. What is the equivalent resistance of this branch? That is R3 is in series with R1 and R2. So R3 is in series with R1, R2 divided by R1 plus R2. So this will be the net resistance in this total branch. So I4 double dash will be in the numerator. What is the resistance in this branch? That is R3 plus R2 plus R1, R2 divided by R1 plus R2. So this is the net resistance in this branch divided by the total resistance in this branch and this branch. That means R4 plus R3 plus R1 multiplied by R2 divided by R1 plus R2. So when these two becomes equal, okay, then you have to add this. So this is I4 dash plus I4 double dash. This will be the net current that will be flowing to the R4 resistance when you have applied both the sources. Okay, when you applied both the sources, the net current that will be flowing through R4, that will be the sum of I4 dash and I4 double dash. Now you can solve this problem using nodal and mesh analysis, but again, using superposition simplifies the circuit by many times. It simplifies the circuit. Now, see this again, there are two independent sources. One is 5 ampere, the other is 20 volt. Okay, then what you have to find the current through this 3 ohm resistance, through this. You have to find out the current flowing through this 3 ohm resistance. You can apply mesh analysis, you can apply nodal analysis and able to find out what is the current flowing through this 3 ohm resistance. But since we are studying the superposition theorem and we are trying to see that where we can apply. So does this circuit satisfies all the conditions? The first condition is the active circuit. That means it should have some active element. See, it has different sources, different independent sources. So definitely it is a active circuit. Two or more active elements or sources. Here also you can see there are two. One is a voltage source and another is a current source. So two independent sources. Third, linear elements. Please re-explain previous example. Okay. So this was the given circuit. That means two sources were there. One was a voltage source and another was a current source. Okay. Now let us say you are asked to find out what is the current flowing. What is the IR4? What is the current flowing through the R4 resistance? That means we have to find the current I4 through the resistance R4 due to these two independent sources. That is one voltage source and another current source. This is the question. Have you understood, Rajveer? What the question is asking you? It is asking you to find the current through the R4 resistance when there are two sources, two independent sources. One is a voltage, one another is a current. Now you can apply whatever theorems we have done, that you can apply and find out. But here in superposition theorem, it simplifies the problem. That means what superposition position theorem is saying is that, let us say you have deactivated the current source. Again, deactivating current source means replacing the current source with open circuit, because ideally a current source has infinite resistance. Circuit. No current will be able to pass. So you are only considering this part of the circuit. And you should what you should find here, you should find what is the current flowing through this IR4 when you have deactivated this current source. That means, let us say that is denoted by I4 dash. So through, again, whatever technique you want, whatever techniques you have learned, okay, using simple current division, what you will be able to find out, when this current source has been deactivated due to this voltage source, what is the current flowing through this R4? We have we have considered it to be I4 dash. Given R1, R2, R3 and voltage V, you will be able to find out that current. So you have found I4 dash due to the voltage V, the current, what is the current flowing through this R4? Next, what you do, you deactivate the voltage source. That means deactivating voltage source means replacing this with a short circuit. Okay, now this current source is there. Due to this current source, what is the current flowing through this R4? That is I4 double dash. In whatever way you want to find, you can find it. Okay. Now the net current that will be flowing through this R4 resistance when both the sources will be connected. That I4 will be equal to I4 dash plus I4 double dash. Okay. So let us see this example. It is asked to find out what is the current flowing through this 3 ohm resistance, 4.75. Okay. What is the current flowing through this 3 ohm resistance? That has been asked to find out. Okay. It has two sources. One is a 5 ampere current source, one is a 20 volt voltage source, and some resistance are there. So first we'll deactivate it, let us say the voltage source. So deactivating voltage source means replacing with a short circuit. So that's what it has been done here. It has been replaced with a short circuit. The moment you replace this with a short circuit, this 4 ampere current will be 4 ampere voltage, 4 ohm voltage is, 4 ohm resistance is of no use, because current will try to flow through the path which offers least resistance. So this path offers zero resistance, the whole amount of current will flow through this. Now you have to find out what is the current. Let us say this is I3 dash. The current flowing through the 3 ohm resistance, and dash means you are finding out the current for this 5 ampere current source. Okay. Now you can see there are two branches. That means there is a current source. That means here 5 ampere current is flowing. Now here there are two branches happening. In one branch there are two resistances, 5 and 10. So you can sum them and you can write it as 15 ohm. In this branch, again, there are two resistances. So the net resistance value is 2 and 3, so 5 ohm. So this 5 ampere current will be divided into two parts. We are interested in what is the current flowing through this path. So using current division rule, your I3 dash will be current division rule. That means what is the voltage in the other branch? That is 15 divided by 15 plus 5, that is 20. Okay. So 3 by 4. This much amount of current flows through this 3 ohm resistance when you have applied only the current source, and it is in current will flow like this. So this will be in downward direction, in this direction. In downward direction, 3 by 4 ampere current is flowing. In downward direction, 3.75. Okay, it will be 15. And what is the total current? Total current will be 5. So 5 will be multiplied. Okay, so as a result, it will be 15 by 4. Okay, 5. I forgot to multiply the 5. That is the total current. 5 will be divided into two parts. Okay, so 5 will be multiplied. 15 by 4 ampere in downward direction. Next, what you do, you deactivate the current source. Deactivating current source means you replace that with open circuit. Okay, this circuit will look like this. You see this. So you are deactivating the voltage source. In the first part, what you have done, you have deactivated this. That means you have replaced this with a short circuit. Now you will be deactivating the current source. That means it will be an open circuit here. So the circuit will look like this. It will be it will look like this. That means these are all resistance. So these resistance are in, you can see all these resistances are in series. So 10, 5, 2, 3, all in series. So you can add them. So it will be 20 ohm. So here it will be 20 ohm. Here it will be 4 ohm. And here you are giving the voltage of 20 volt. And what you are trying to find, you're trying to find what is the current flowing through this 3 ohm resistance that is there in this branch. So let us say this is I3 double dash. So I3 double dash, again using I3 double dash, you can find out by first find out what is the current that will be flowing, total current. Let us find out what is the total current that will be flowing. That is 20 divided by the parallel connection of this 20 and 4. So 20 multiplied by 4 divided by 24. Okay, so 24 by 4, 6 ampere. So 6 ampere current is the total current that is flowing through here. 6 ampere. Now 6 ampere current will be divided into two parts. This part and this part. We are interested in this part, I3 double dash. So I3 double dash will be using current division rule. Okay. So using current division rule, if you are trying to find out what is the current flowing through this branch, in the numerator you have to write out, we have derived this thing. If you remember the current division rule we have derived. So please go and check that. So you are trying to find out what is the current flowing through this branch. So in the numerator it will be 4 divided by the sum of this, that is 24. multiplied by what is the current flowing, that is 6, that is 1. Okay, so 3.75 due to the current source and 1 ampere due to the voltage source. Now, what will be the direction? The direction will be in opposite direction. If you see this, the direction now is flowing like this. In the earlier case, the direction was this. So, in downward direction, through this 3 ohm resistance, from top to bottom, it is 3.75 ampere. From bottom to top, it is 1 ampere. So, which one is greater? What is the net current? Net current will be in downward direction and its value will be 3.75 minus 1, okay, 2.75 ampere. You have to see the direction also. Due to this current source, the current that was flowing through this 3 ohm resistance was in downward direction from top to bottom. And the value was 3.75 in downward direction. Here, the current was in this direction. If you see, the current was flowing like this. Here, somewhere the 3 ohm resistance is there, 3 ohm resistance. So, current was flowing like this, or in bottom to top. In bottom to top, it is 1 ampere. And in the previous case, top to bottom, it is 3.7 ampere. If you take the difference will be in downward direction, okay, because 3.7 is greater, 7.5 is greater than 1. So it will be in downward direction and the net current will be 2.75. Okay. So let me know if you have any doubt here. Let me know if you have any doubt. If you have no doubt, then we will start with the tutorial class. Okay. Okay. Then we'll start with the tutorial class. You already know who is your tutorial instructor. Again, the tutorial sheet will be shared in Google Classroom. This Norton's theorem, superposition theorem, and Thevenin's I will share in Google Classroom today. Okay. No, you have to just log in here. Log in here and download. You can download it. Exactly. No problem. Okay.
So hello class, please everyone reply in the chat. Am I audible? Okay, okay. So did you get your tutorial sheet? Should I share it? Okay, I'm sharing. So we will start the tutorial sheet. So today's topics are KCL, KVL, nodal analysis, and mesh analysis. So please reply in the chat till which topics are covered in the last class. What was the last topic? Anyone reply? What was the last topic covered in the class? Superposition theorem. Okay, 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 okay. So I think mesh analysis is also covered. So okay, then we can proceed with this tutorial sheet. Okay. So should I start telling or you will give the answers and I will then explain if there is any doubt? So now we are having question number 1 on the screen. So if anyone have already solved this, post your answers in the chat. If there is any doubt, I'll explain that question. Damn. Okay. Okay, I've got one answer. More answers. You have only got one answer. Are you guys there or just okay? So I'm seeing no answer. So I will explain this first question. Okay. The screen is visible, right? So let us see. So we're having, so we'll solve from the right side. As we can see that the right part of the circuit is a bit complicated. So we'll start from the right side. So we can see this 12, this 12 volt and 6 volt are in parallel. So you have to do this. R equivalent is equals to 1 by 12 plus 1 by 6. Any doubt? Okay, I will be doing this in parallel combination. So this will be 1 by 12 plus 1 by 6, which is equals to 2 into 12, which is equals to 12 upon by 3 is equals to r, which is equals to 4. So by solving this 12 and 6, you will be getting an equivalent of 4. As you have got 4, now we are having 20 and 80 in parallel combination. 20 plus 80 is equals to r equivalent, which is equals to 80 upon by 5. So we have got 80 upon by 5 is 80. This you have got 4, and then you have C 80 and 20 in parallel combination by 20 is equals to 1 upon by r equivalent. This is equals to 5 80 upon by 5 is equals to 6. We have got 16 over here, so we have this 16 plus 4, these are in series. So when you add both of this 4 and the 16, you will be getting 20, which is equals to 4 plus 16. So now if you see this entire part, after solving you have got 20, and this 20 part is in parallel combination with 16. So 20 plus 16. That's gonna be 60 divided by 4. Be 1, 2, 0, 15. So you have got 15. After solving complete this equation, you have got 15. Now this 15 and the 15 which I've got over here, both are parallel. So solving again 15, 15 parallel combination, the R equivalent which we'll be getting is equals to 7.5 ohm. After solving the final circuit will look like this is your 2.5, and again you will be getting 7.5. This is 2.5. So the equivalent resistance is equals to 10 ohm. And in the question you are also asked to find the current, right? So current is equals to V upon by R, which is equals to 35 divided by 10, which is equals to 3.5. Okay, is it clear? Yeah, you have the access to talk. You can say yes or no.
Yes, sir.
Okay, okay. So let's go to the second question. So once look into this question. The 60 volt light bulb in figure 2.2, this figure is rated at 120 volt. Calculate the Vs to make the light bulb operate at its rated condition. Okay, once you try to solve this. Okay, okay. If you got any answer, just post in the chat. I will be checking, and if it's not clear, I will solve this. Okay. I've got one answer already. Few more answers.
फिफ्टी साउंड देख लियो तो 50 साउंड देखो अरे 4-5 हजार है वही उन लोग
So here in the figure 2.2,
Mhm.
so there is a wire at the bottom, I think. It's not visible there.
Yeah, it's wire like it's same as in the figure 2.3. It's like short wire.
Okay, sir.
Okay. Okay, so the time is 4:15, so we'll wait for 2 more minutes. I'm expecting for more 2-3 answers. Yeah. Okay, I will try to explain. I've got one right answer and one wrong answer. So, okay, is the screen visible? Figure 2.2.
Yes, sir.
Okay. So let's see. The final aim is to get the value of Vs. So we know V is equals to I into R. So if we are able to find the entire current which is passing through that Vs, we will get to know, as we are given with the resistance, we have to find the current which is passing through Vs. If we get, then we can multiply I into R and we'll be getting Vs which is passing. So, so we'll be getting the voltage over there. Now, in the question we are given that the bulb is operating at a power of 60 volt, and the potential is given to be 120 volt. Okay. So that means if we take this as our reference node, we'll be getting a 0 volt over here. And for this, it should be 120. Okay, is this clear? Okay. So we know in parallel connection, the voltage will be same. So as this is 120, as this bulb and 80 ohm resistor is connected in parallel, this will also get the same potential 120, and here we'll be getting 0, and here also it is 0. Okay. Now, from the power theorem, we will try to find the resistance the bulb is offering. So we have power is equals to V square upon by R. So from this, R is equals to V square. That is 120 into 120 divided by the resistance. Okay, we have took resistance to the left hand side and power to the right hand side. So power, we have it's already given 60. So 2, it's like 240. So now we have got the resistance through the bulb is 240 ohm. Okay. So we know KCL that if we assume that the current passing through Vs is I, then I will be divided into I1 and I2. So you will be getting I is aim is to find I1 and I2. Okay. Now for I2, we are having the voltage is 120 and the resistance is 80. So it's like 3 divided by 2, 1.5 amps. And for I1, V, what is V? It's 120 divided by 240 is the resistance which I got, that is 0.5 amp. So the net current passing through 40 ohm resistor is 0.5 plus 1.5, which is 2 amperes. You have got this. Okay. Now, as the current passing through 40 ohm is specified. So 2 into 40, it will be giving us 80 volt. So now here we are having Vs is equals to V plus the voltage of the bulb which are having. That is equals to 80 plus 120, which is equals to 200. Okay, is it clear? If you guys respond quickly, then we can end up the class quickly. I will take your attendance and I will leave the class, okay? Okay, now we'll go to the third question.
So here, why didn't we apply the direct voltage divide?
What voltage divider?
Like finding the equivalent resistance at of the parallel connections in bulb and the 80 ohm resistance, and then we can apply V R2 upon R1 plus R2.
Yeah, you can also do that, but to make you, as this is a tutorial session, R is equals to V square upon by R, to just introduce this concept, I've used this concept. Otherwise, you can also do that. So to get the equivalent resistance, you have to find this, right? So to find the resistance through the bulb, you have to know this formula. So to introduce you with this formula, I've used this approach. Okay, Akash.
Yes, sir.
So look into this third question. I see Irene Agarwal is always solving quickly. Do you have the solution set or what? Your friends didn't got the question and you are like so quick. Already solved this shit. Okay. Okay, more 2 minutes for this third question and I will solve this again. Any more answers? Ayush Kumar, what is 9.4? So the first question here is to find the current through each of the bulbs. Okay. Okay, what about you, Akash? Have you solved this?
Solving, sir. Made a mistake while calculating.
Okay. And parent series. Okay. So I see most of your answers are going far away from this actual solution. Like the answer should be less than 1. Most of your answers is like near to 10 and between 1 and 10. Okay, so today we are having like around 10 questions. So I will solve this third question now. So in series now we will find what the value of I. So now see, we are given that all the bulbs are connected in series combination and we are given with a voltage of 120. So now we have to find the current. So according to power theorem, we have P of 30 is equals to V square divided by R, right? Okay, Ayush Kumar. Okay, Ayush Kumar, your answer is right. That's fine. Okay. For P30, you have to do the same to get the resistance of this 30 volt bulb, and you have to apply this formula for each and every bulb. So for P40 and P50, so after getting the resistance, as these resistance are connected in series combination, you have to add the equivalent resistance is equals to R through 30, R through 40 plus R through 50. So we'll be getting the R equivalent value. After getting R equivalent, the current is equals to E upon by R. So here you will be getting the current, and the answer is 1.06 amp. Okay. So you have to use this theorem. And this has to be applied to all the bulbs, and then you'll be getting equivalent resistance, and using this Ohm's law is equals to V upon by R, you'll be getting the current value. Is it clear? Rajveer, got it now? What about you, Akash?
Yes, sir, got it.
So that's about the part A. Now we have to find the power in parallel. Yeah, we can use P is equals to I square R, but here you are not given with the current, right? The question is to find current. So if how can you use this P is equals to IR? If you know the value of current, then you can use that formula. Now we will be using that because in series combination we will have current. The current through all these bulbs will be same. No, so for this now we will be using, for the second step we'll be using that. Raju, is it clear? So now we have found the power. So for now we have found the current, right? So that is 0.106. So now the power through this 30 bulb is equals to I square into R. Now we'll be using this formula. So see, we have also got this resistance value. From this, we'll be getting the resistance value. So I have this value, which is 480. R30 is equals to 480. So 0.106 whole square into 480 will be giving power of 30. In this way, you have to find each and every value. So using the same formula for P40 and P50, and you will see that there is a drastic drop in the power value. See, it's like in the order of 0.1. So if you square, it's gonna go to 0.01 into something. So it's gonna be quite less. So that value is like P30 value is equals to 5.432. So if we connect all these bulbs in parallel combination, we'll be using this formula, and then we'll be getting that this 5.432 volt will be the power through this. And
Sir, sorry to interrupt you, sir, but I'm getting slightly different values for the powers of individual elements.
resistance.
Resistance are same as the values that you have taken, but the power consumed by each individual element.
So how did you approach that? You can discuss.
So I applied the same formula as you did, V square upon P, to get the individual resistance.
Mm-hmm.
And I got 480 ohms resistance for the 30 watt bulb.
Yeah.
And 360 ohm resistance for the 40 watt bulb.
Yeah, right.
And the 50 watt one has a resistance of 288 ohms.
Yeah, nice, correct.
So after applying that, the total current in the circuit is around 0.09.
What's the total resistance you've got? 1128, right?
1228.
1128. It's 1228. Let me check. What are your values? 480 plus 360
Plus 288.
plus 288 plus 360.
Yes,
11
sir.
It's 1128. It's 1128. 1128 and that divided by 120 divided by 1128. 20 divided by 1128. See this, it's like 0.106. Okay, Akash.
Yes, sir. Now I got the error.
Mm-hmm. Okay, 112, right. So in the second part, so this we can apply this formula: P is equals to I square into R for each and every bulb, and you will be getting the power consumed by each and every bulb. So that ends the question here, and like the bulb will figure a connected file. Okay, it's done. It's done. I hope this question is clear for everyone.
Yes, sir.
Yeah. So look into this fourth question. This might be in your JEE syllabus, right? This delta Y transformations. So you can apply one hint is like you can apply the delta by transformations here, and it's quite easy to solve. You can solve it. Yeah. Right, right. So only 1 minute for this question. So quite easy. You can solve this. Do it quickly. We have got one answer. Okay, two answers. Yeah. So Akash, tell me, is it? Do you know this question, this concept?
Yes, sir. I'm aware of the concept, but yes, I am unable to apply it currently. Facing
Okay.
problem in the application here.
So you can see this cursor, right?
Yes, sir.
See, the only one thing you have to do is like you have to stretch this resistor from here to in front of this. It has to be taken in front of this, and this two will be in series, and this two will be in series, and this will go in front of this. And for this formula, you have to only apply one simple formula. I will write that formula, and it's all done.
Yes, sir.
this has to be transformed into this. So this is your A, this is your B, C, D, E. So D, E are same, and the C goes to the front, and B, A and B. So only one thing we have to do is like the resistance of D and E will remain same, but the resistance of A, B, C will change. Like the resistance of A will be resistance of B into resistance of C divided by A plus resistance of B plus resistance of C. So and similarly for resistance of B, you have to replace in the numerator RB with RA, and for resistance of C, you have to replace RC with RA. You have to calculate, and as the resistance given is 1, right? So it's gonna be like 1 by 3, 1 by 3, it will remain the same. So it's 1, and it's 1 divided by 3. So now we can solve this. It's in series, both in parallel, and this entire circuit will come into this. So R equivalent plus this comes to be in series. So this will be the equivalent. And you have to do the same for the above and below, and it's done.
We can also apply Wheatstone bridge rule.
You can also, yeah. Yeah, there are multiple methods you can apply, and you will get the same. Okay, Akash, is it clear?
Yes, sir.
So look into this fifth question. In previous tute, you have solved these questions based on nodal analysis. So this might not take much time, just 2 minutes. So Arun Agarwal, tell me your answer. You are not posting the answer from the previous question. 60. That's right. So Arun, can't you unmute? Once please unmute. No problem. If you are in laptop, no worries. Once try, I will check your voice. Yeah, you try to explain this question to your friends. You use mesh analysis. Okay. Okay. Okay, Rajbir, have you got any answer? Akash, have you got any answers?
Not yet, sir.
You've solved this in the previous, you can expect questions from this topic. So do it quickly, it's important a bit. Mesh and nodal analysis will be important. So one thing I recommend is that you go to YouTube and check for these gate questions. They are a bit tricky and you try to solve them. So most probably, I think you'll be getting gate questions in your midsem and endsem examinations and quiz. So once look into the gate questions. ID. I don't know about this Shai Deepu book. During my first year, I've just used this Gate Academy to solve these gate questions. Like during our time, 75% of the paper was MCQs. So you have in 180 minutes, in 120 minutes, you have to solve 150 questions or something. In 50 or 75 questions, you have to solve in 120 minutes. So it was a paper. So you have to make yourself so fast. Like for this question, if you are taking 5 to 10 minutes, then it's gonna be so difficult.
So this pattern you are telling, it's of our mid-sem examinations.
Yeah.
75 questions in 120 minutes.
Oh yeah, 120. Yeah. So during our time, we have we have that pattern, but I don't know about this pattern. This time for you, it might be different. But still, if anyone want to give gate in your future, this course will build your fundamentals in electronics. So once look into this. So this is your solution for this Swift problem. You have to just take these two nodes, A and B, and you have to make equations like VA minus VB upon by VA minus of 0 divided by 20 plus VA minus VB divided by 10 and VA minus 40 divided by 20. This is the equation 1 for node A. And for node B, you can take VB minus VA by 10 plus VB minus 0 by 10. And as this current is opposing this flow, so it's minus 4 Ix is equals to 0. And you have got Ix over here. So you can get the value of Ix from this equation. So see VA minus 0 by 20 is equals to Ix. So substitute that value here and solve this equation 1 and 2. And it's done. So one check this question if you want to play. Akash, have you got this?
Yes, sir.
It's already 4:51. So once look into this question number 6. Same, you have to apply nodal analysis to this 2.6.
Sir, can you please zoom into the question a little bit? Okay, sir.
Here also you have to use the same approach. Like you are given with node 1, 2, 3, 4 mentioned in the question. So apply the same formula like V1 minus V2 by 1 plus. For each and every node, you will be getting 4 equations and you can solve this. Five. Okay, Raju. N is equals to 20. Let's check. What about V2, V3, and V4 are in? Point. Right. Now give me the answer for V2 and V4. Rest of all, are you solving or not? I only see 4 to 5 people in every class speaking. Rajveer, Arin, Ayush, and Jakash. That's it.